firms that are actually building the projects we heard about on Friday. Bill Allen, Senior Vice President and Director, Business Development from the Hunter Roberts Construction Group, will moderate.
Good morning, everyone. Thank you for that introduction, Nancy. I'd just like to thank yourself and Mitch Simpler, as always. The day is well set up. Fantastic symposium this week. It's my privilege to be here representing Hunter Roberts. I'll moderate a really wonderful panel. We'll thank all the sponsors and the supporters. Very talented and knowledgeable panel we have here with us today. They're going to share some of their lessons from a selection of their life science projects. And then, as Nancy mentioned earlier, we will follow that up by a little roundtable discussion on some of the important topics, and then get on to some Q&A, which I think is the intention also. So just to run through who's with us, you're going to hear from Brooks Slocum, my friend from SGA, architectural firm. Don Weinrich is also, I think, intending to join us from Eniad. Matt Malone from Perkins & Will. Chris Horch from JB&B. Joe Whalen, my friend from Lend Lease. And last but not least, Theo Diamantis from Skanska. All wonderful professionals. I know them all fairly well. A couple of new ones there for me, but we're going to get right into it. So I'm going to take everybody in the order that we have on the schedule here. Dawn has just joined us. Good morning, Dawn. And so Brooks, could you give a little introduction of yourself and some information on your firm's projects and what you're working on right now? That would be useful for everyone, I think.
Sure. Good morning, everyone, and thank you guys for being on with us. It's what a great panel. Obviously, the folks that that are on here are excellent in the field, and it's an honor to be with you all today. SGA is a Boston-based, New York-based firm. We have been working in the life science industry specifically for well over 10 years now. We have currently 4 million square feet on the boards that we're doing, and we have projects in both New York and the Boston metro area. Next slide. I'm the studio manager for the New York team, and we are doing a lot of projects that are around the country, some that are kind of currently working with different developers and workers and builders like the folks here. We have awards recently just for some of the design, some of our passive house, which we're trying to bring some of that technology into our life science buildings because of the energy requirements. And those are some of the more important pieces of getting to the next level of life science we see. Next slide, please. One of the things we do as part of our design with people looking to do life science buildings, there's really a big difference in regards to considerations, and they range from the envelope all the way through structure and core. And these are some of the stuff that we look at and go into intense depth. This is a process that everyone kind of wants to take a look at when we're doing this. But next slide. We then work with our partners, and much like with Chris on JB&B, we look at the differences between an office and a lab project, what the differences are, where the building might overlap. Next slide, please. And then there's this big difference that is starting to evolve, especially in the New York market, but we see it also in our Boston projects, is the difference between lab ready and lab friendly. This is a building that has half of the building is lab ready, which you can kind of see on the left there, and lab friendly, which means the building is ready to go. All the infrastructure's there, all the shaftways are there, ready to be knocked out, but we're ready to build the other half of this building. But at this point in Kendall Square, that side of the building is the corporate headquarters, which is kind of interesting. So it's not yet ready, but if need be, the buildings can convert. And that's something to always keep in mind as we're looking at buildings, having that flexibility for the next level. Next slide, please. And then that same analysis is done. What is lab ready? What is lab friendly? In New York, it's an important feature when we're looking at a lot of the sites. what buildings can be ready, what buildings, have the better infrastructure to upgrade to. And this is some of the analysis that we'll do ongoing as part of the process. Next slide. In New York, we have several buildings that are up, some in New Jersey with 95 Green. We're also working a little bit further out with Thor on the Center of Excellence. We have a couple other buildings that we've been evaluating, and as I'm sure many people on the panel here, and we've done it with several folks on this call, looked at a lot of different buildings, and not every building fits the envelope of life science. Next slide. And we do, a fairly good review, and until the building kind of meets enough criteria, both economically and physically, we're going to kind of take a look at it. This is 95 Green. It's a 340,000 square foot lab ready. We're with Thor Science, and we're just starting to get to we finished the drawings, and we're just getting bids now, and we're about to start construction on that project. Next with Vanderwell. Next slide. This is the next one, is just a quick view of how we're working with a campus out in Jersey for another 80,000 square foot building. A little tribute to an old past architect that we love. Next slide. And then this is one of the other more important pieces is incubators and accelerators that we focus on. These are really important feeders. And I think, Nolan on Friday talked about this. These are the ways in which all of these lab spaces get built out. And we do a lot of those both in Boston and in New York. Next slide. In Boston, I just want to say one thing, about the Boston market. We're probably one of the leaders and have in the Boston market in regards to square footage and buildings built. We've helped develop a lot of these subclusters. Some of our buildings were the first in these subclusters, which are now taking over the market. This is a really important thing for New York because we have, as I think, Nancy, you mentioned, super clusters. These are the things that we're trying to kind of bring together, but in Boston, it was built one after another. And this is kind of the same, a different format for New York, but it's something we should keep in mind as we move forward. Next slide. And on the boards, we have now about 4 million square feet, as I said earlier, in different stages. Some are under construction. We have a bunch on the boards right now with some of the larger institutional players, both in New York and Boston. Next. And then, we're playing with a concept with a few folks here about a vertical orientated lab buildings. And this is, I think, the next step for New York to also consider how much higher can we go with these buildings. And a lot of it has to do with exhausting the fumes. But this is something that as we study, and we're currently looking at a few buildings right now, how does that happen? And this is going to be the kind of the key in New York, I think, to see how tall we can go with these buildings and be efficient. Next step. This is the one little thing I want to leave with the group. This is the typical drug discovery pipeline, and it goes all the way through to packaging and sales and corporate headquarters. But it starts with basic research, computational biology and vivarium, and moves on through. In New York, next slide, we're kind of in the beginning phases of this, and I think the takeaway from this is New York has a long way to go down this process to become the juggernaut, but we're definitely on our way there. And I think if we can get these three elements, the basic research, computational biology, and vivarium locked in, I think we have a great future to fill out the rest of this chart. Next slide, please, and thank you. That's us. Thank you from SGA.
Thanks, Brooke. That was a very good synopsis, and thank you for that. I don't want to turn to Don Weinrich. Don, good morning. Don, would you like to, good morning, how are you? Would you like to give us a little,
sure.
A little bio of yourself and your firm, and then take us away?
Sure, no, happy to do it. And there we go. Okay, so here's our little deck. So I'm Don Weinrich, partner at Eniad Architects, been with the firm for over 30 years, worked in many different building typologies, but certainly a heavy dose in the life sciences. So next slide, please. So just in terms of our firm's profiles, a little bit about us. I think it's significant that we get a tremendous amount of work is from repeat clients, and we have a very high retention rate. Almost half of our staff have been with us for 10 years, and the work is both performance focused and definitely design focused. We've won a lot of awards for our work. Next, please. The firm was actually founded in New York City, so it's our home base. Our other office is in Shanghai. And in the course of working in New York City all these many years, we've done a lot of projects working in all of the boroughs and also on what I like to call the far west side over in Jersey City. We're working there as well. And that's allowed us to develop, I think, a significant expertise in how to navigate the city's unique regulatory framework. Next, please. To date, 22 of our lab projects have been built throughout the country. That includes New York City. Its totals over 5 million square feet completed, and over $3 billion worth of construction contracts. And in the next slide, you will see some of the ways in which we like to share our knowledge with the life sciences community, particularly the commercial life sciences. We held a symposium last November before the world changed to invite a number of thought leaders in various aspects of this somewhat niche field in New York to come and share what they know. It was well attended, and as soon as we get the all clear to get back together, I'm sure we'll be organizing another one of these. Please go on. So next slide, please. So throughout the firm's history, we've engaged in a number of different significant lab typologies and developed considerable expertise in them. Of course, there's the campus lab, freestanding building on a suburban context, very often associated with the university, more and more often being associated with a kind of knowledge district and including incubators and relationships for with commercial life science development gets integrated. Next, please. And in New York City, there's this unique typology, which Brooks began to talk about in his intro, which we call the vertical lab. These are high-rise labs above 85 feet. And in New York City, there are special provisions in the code, which were really designed to encourage lab development without such heavy restrictions on chemical concentrations that you would find in other codes. And that has allowed these very tall laboratory buildings. Some of them are 16, 17 floors, and there certainly are some upper limits, but we can go tall in New York, and we've done that on a number of occasions. Next, please. And of course, within New York City, getting things approved is a very particular process. Sometimes it's kind of straight as of right, DOB, fire department baseline of approvals. And in other circumstances, please go on. We have to deal with Landmarks Commission, City Planning Commission, if it's going to be a rezoning of a particular site. So these are all agencies that we have a lot of experience navigating. Next, please. On the topic, and Brooks used an interesting term referring to Boston of the kind of supercluster. There's, I suppose this is another kind of a supercluster here closer to home, and we have to credit Nancy Kelly for this concept of the bioarc. You can see it here mapped onto New York City, beginning in Upper Manhattan, and then heading over to the east side to the large hospital district, and then back looping around downtown, and then even over to Jersey City, of sites that are well connected to institutions of higher education and research. So these, we feel, are providing a well interconnected, highly linked network of districts where life sciences are taking off. Next, please. And again, I don't want to repeat what Brooks was talking about, but understanding where the demands are coming from will certainly help developers decide where in the city the right locations might be to develop a property so that it can feed into these various pipelines. Again, Nancy is really the expert we refer to in understanding where the action is in these spheres. Next. And in terms of how the demand gets met in the city, there are a couple of strategies that we're currently involved in. Adaptive reuse, certainly, it's probably the fastest and maybe one of the lower risk ones. Brand new ground up development, special permits, which involve rezoning, and then looking at options beyond Manhattan. But on the next slide, I wanted to show you something that we just brought online and are happy to make available to developers, is a kind of simple little 10-page white paper to help in the assessment of a property in the city. Primarily, this is focused towards adaptive reuse of office space that might be adaptable to commercial life sciences, to help you get a quick understanding of whether a project might have legs. And obviously there's a lot more work to do, but we go through a rapid assessment regimen. Some of this you can do yourself, some of this we can help you with, and then you'll emerge from that process a bit better informed about what you might be able to do. Next. A couple of examples of work in each of these categories. Adaptive reuse, this is the New York Stem Cell Foundation's headquarters, which is in the Hudson Research Center. I believe it was the first lab that opened in that building on the far west side. Next, please. And building from the ground up, this is on the east side for Weill Cornell, a high-rise lab, the Belford building, and you can see the kind of highly compact efficiency in that floor plate. It's a site that's only 100 feet deep, but it's about 300 feet long, and it laid out beautifully for labs. Next. And in the realm of special permits, which involve rezoning, we're currently doing that on behalf of the New York Blood Center on the east side next to St. Anne's Park. One of the unique aspects of this rezoning was we were able to persuade city planning that a high FAR made sense if we could keep the height and bulk of the building down. So it's sort of a stout tower, if you will, which laid out beautifully again for labs with about a 200 by 200 foot floor plate. Next, please. Almost done, Bill. And then looking beyond the shores of Manhattan to Jersey City, we're currently involved in this development, which was called Crescent Park. I believe it's now been rebranded as the Cove, which is meant to be a complete campus, live, work, play, research, headquarters, laboratories. You might never have to leave. Next, please. And that, of course, feeds into this kind of stacked mixed-use typology, again, similar to what Brooks was talking about, where we can mix different kinds of programs and stack them on top of each other to create a wonderfully dynamic high-rise condition. And the map on the left shows the areas within the city where these types of projects can be fit in under the current interpretations of the zoning rules. Next, please. And then finally, and this is sort of interesting, if you think about that stacked mixed-use typology as being something new, it's also something old. And we pulled this out of the flat file as a project that we did 30 years ago, actually together with JB&B, which was really one of the first of its type of putting housing on top of offices, on top of research, on top of a podium that included a vivarium and accelerator space. So we did that for NYU Langone. So history does go round and round, and we're still very much at this. So thank you, Bill. That's my intro.
Thank you very much, Don. That was really tremendous. Some real projects of scale there, very exciting stuff. Matt, could you similarly, Matt Malone from Perkins & Will, could you give us a little intro and a little bit about your firm, Matt, and what you're working on?
Absolutely, I'd be happy to, Bill.
Thank you.
Yeah, so Perkins & Will is, hello, Matt Malone. I'm a life science technology practice leader for Perkins Will's New York studio. And Perkins & Will is a firm that is one of the larger firms. We've been around for about 85 years. We've got roughly 25 offices and 2,500 employees worldwide. But my focus is New York. My focus is science and technology. So with that, I think we're talking a little bit about these adaptive reuse or renovation projects in New York City. One of them that has been mentioned is the InnoLabs project here, which is a joint venture with King Street Properties and the Gural Group. So this is about a 250,000 square foot building. Next slide, please. I'm going to go through these a little rapid. The building itself, the idea here that we're trying to lend to the creation of a life science cluster or to life sciences in general is the understanding of the need for collaborative space, for social space, for gathering space. The building is intended to potentially house upwards of three tenants per floor. So you may get a large mass of tenants depending upon how the leasing is ultimately progressing. And as a result, these ideas of these social spaces, these gathering spaces, next slide, please, become very, very important. So the idea here with this building was to try and make certain that the building had the space for that community, the ecosystem within the building itself to inhabit. But then even beyond that, the Long Island City neighborhood further enhances that by having additional offerings outside the door to offer. So next slide, please. So the laboratories themselves up on this particular high elevation laboratory looking back towards Manhattan offer some really interesting views. You get the kind of the gritty urban context that Long Island City offers, and then out the window you can see across the river to the healthcare corridor that Nancy was referring to, directly over, see the bridge in the distance, directly over the Cornell Technion campus. So it's a pretty interesting vantage point that I think places only like Long Island City can offer. You don't quite get those same views in Manhattan, of Manhattan. Next slide, please. So this is the Hudson Research Center, which at 619 West 54th Street, which has been mentioned a few times already. This particular space, and every project I'm going to show you here actually is developer-based or developer begun, and in some cases shifted gears from there. So this is a perfect example. Taconic had developed this space as a pre-built laboratory environment in order to entice tenants. And it worked out well in terms of the ability to turn over to Hybercell. So Hybercell came in previous to the completion of the project, and we were able to, because of the intent of flexibility within the design of this space, quickly pivot this to specific needs of Hybercell, and ultimately they were able to take occupancy in a very short period of time, which was crucial to them taking the space in the first place. Next slide, please. But again, you'll see within all of this is this idea of having the appropriate amount of social space, the amount of collaborative space that connects the laboratory to the office, kind of the lab environment where the bench work is done, and the office environment, which is the safer environment where we would encourage all the scientists to do their write-up work, not necessarily in the laboratory, creates this schism, and in that we tried to locate the social spaces. Please, next slide. And so you can see here the connection in the office space to the right, but the transparency into the laboratory to the left, which we felt was particularly valuable. And I can tell you that Taconic is interested in continuing building laboratory space in the Hudson Research Center. So we're very excited about that. Next slide, please. This is a view from the laboratories all the way through to the office space, just to try and show how we were maximizing the transparency within the laboratory environment. Context is important in these projects. This is the Memorial Sloan Kettering laboratory on 64th Street. And where I bring context into this is we talk about collaborative space. We talk about bringing things like natural light into these laboratories, but also we want to be contextual to our neighborhoods. And that's also important to make sure that the laboratory projects kind of take hold in New York City. So this is one where, next slide, please, where we were locating ourselves in, an Upper East Side residential neighborhood and needed to make certain that the building itself was not an obnoxious neighbor, that it fit in with its environment to some extent. So some of the things we were trying to do were look at the sun angles and how the sun approached the building, because it is south facing, but also we wanted to try and make sure that the building elevation, the height, the datum lines were correctly addressed. So next slide, please. In order for us to do that, so this is, you get an example of the facade of this building. The building design is based upon, again, sun angles. The idea of where we put frick patterns was based upon the hours of the day as the sun moves across the sky, so that we could maximize natural light into the laboratory environment. Next slide, please. But also, as I mentioned, the idea of being contextual, the building itself wanted to maintain the datum lines that were within the residential neighborhood, which caused us to really look closely at what we were able to do from an MEP integration perspective. The lower 2 floors of this building are predominantly mechanical spaces that are fed from an areaway you see in the back of the building there, to feed air down. So this was something that enabled us to focus the laboratories above and keep the elevation of this building. Despite what everyone says, I completely agree. The idea of tall laboratories is something that we have in New York that many other places don't have. But this was an argument where there was an interest in making sure we were staying contextual to the environment that the building was being placed. Next slide, please. So this is an idea of inside the laboratory. This is a diagnostic laboratory as opposed to an R&D laboratory, which goes to what Brooks was suggesting about the full spectrum of life sciences in a place like New York City. Next slide, please. This one is not a lab building at all, but I bring it up because it is very crucial to some of the things we're talking about today. So this is the North American headquarters for Unilever Corporation. And this project in specific, next slide tells the story better, is an existing building or an existing collection of buildings in suburban New Jersey. And Unilever was interested in looking for other options. And through the developer, what we were able to do was convince them to kind of stay in their location. If it made the most sense for them, we could make this building something that better fed their need. And their need being, we want to try and make sure we have a sense of place and we have a certain connection to the urbanity. The views from Englewood Cliffs here to Manhattan are actually pretty spectacular. So they weren't interested in necessarily doing away with that. But in order to make this happen, we were trying to create these collecting spaces, repurpose the building specifically. And in this particular case, an enormous amount of technology was integrated into it, which I think is going to become more important as we move forward in our post-COVID world. So please, next slide. So there you get the idea of, and forgive the drama of the rendering, but you're looking at the George Washington Bridge with the sun kind of peeking over the skyline there. And this is the overall collection of the buildings as it was repositioned. Next slide. And the interior space that was created, which was previously the unused space between the buildings, there was an elevation change we needed to make. So we created this environment that became a large gathering place for the entire of Unilever. And this is actually an outdoor space that has just been kind of roofed over, and in fact is a very, very moderately conditioned space. As a result, it is essentially a 3-season room, for lack of a better description. Next slide, please. And this speaks a little bit to the technology integration that I was referring to. So this is a smart building. This particular building really, really took advantage of a lot of IoT components, which I think, again, as we're getting into an environment where we need to maintain things like social distancing, some of that live integrated information feedback enables, in the case of this building, it enabled Unilever to, in theory, shut down and reposition all of their staff during summer hours. If they didn't need to keep a building online, they could tell all of their employees with flexible seating to move into another building. But in the case of, say, COVID, this enables them to spread themselves out a little bit more and understand exactly who is there and where they are, so that they know that they're maintaining their social distancing requirements. Next slide, please. And this is some of the interior of that space. As you can see, it was an existing waffle slab building. So we wanted to try and make sure that we were, exposing that a little bit, giving it a little bit more of a industrial life to the building, and bring a little bit more color and flavor to it, and create these environments where people could, like I say, it was all flexible seating environment. Choose your seat for the day. Everything is interconnected and wireless. Next slide, please. This is for the Prism Group, the On3 development in Nutley, New Jersey. So what Prism has done is they've taken over the former campus for Hoffman LaRoche in Nutley, New Jersey. And while there are very few elements of the old Hoffman LaRoche campus still in place, they've recognized, similar to what we're talking about everywhere, the potential of creating a cluster. You start to see this happening now, I think, a little bit more in the suburban surroundings of New York. Mm-hmm. This one Molecule Drive is a proposed property that shows, the On3 development is one that has residential component to it, one that has retail component to it. There is a medical school, the Hackensack Medical Center has their medical school here. And beyond that, there's other industries, including a pilot plant, I believe, that is in development for a group that came out of New York, a Modern Meadow on this campus. So this is something, next slide, please, that is a bit speculative, and we hope to see this happen as the other buildings that are currently on campus take hold. Next slide. Something that's particularly unique about this campus is that it has its own cogen environment. So it's incredibly energy efficient in that regard. That was something that the Roche people had put in place. Next slide. So this is a somewhat older project, but I brought it up because I think it's kind of pertinent as well in today's day and age. So this was originally developed by Biomed, and then eventually, built to suit, and then eventually taken on by Regeneron. So Perkins Will did the core and shell of this building for Biomed Realty, and then ultimately did the fit out of this building for Regeneron, or these buildings, I should say. And I think what's pertinent here for me, apart from the growth out, to the larger supercluster, Brooks had mentioned the idea in the market in Boston that you're seeing, this market move further and further out as New York develops. I think we'll try to see some of the same things happening in the New York region as well. And this is an example of that. The next slide, please. Something that I don't want to claim prescience to, but at the same time, in an environment where we're dealing with a global pandemic, and the need to have outdoor space and connection to outdoor space, the ability to go outside and still have gathering and collecting space so we can still collaborate is important. And that's what you're starting to see here, the idea of generating something of a campus quad. Next slide, please. Which has a high visibility from all points of the buildings, looking out to that central space. And in the exterior, there was a lot of gathering spaces, a lot of meeting spaces that were designed in to create the sense of community. Next slide, please. That I think, you can start to see the yellow portion of the slide there on the right is that gathering space and how everything is somewhat referential to it. The other thing that I think is interesting and pertinent on the left-hand side here is the idea of having a front door for visitors that was different from a front door for the local inhabitants of the building. And that separation in an odd way has, again, proven to be very, very useful in a situation such as this. Next slide, please. And then on the interior, we've kind of taken it as a pod approach. So all of these buildings, which look somewhat organic in their shape, have become, in reality, fairly regular and flexible from the perspective of a planning design, so that we could manipulate and change the design as necessary for the specific needs of the science. Next slide. And that's what I've got to offer you. I wanted to just try and make sure that we were keeping attention to the current things of the day that we're seeing. So I hope that was beneficial.
Thank you, Matt. That was very interesting. I was happy to see the 64th Street lab up there. I can remember how much rock we took out of that basement there. It's amazing. Right?
We have one question from the audience that I wanted to get to before we go on. Considering, this is from Mark Rosenberg, considering the unique specifications of a life science tenant, how are you able to offer pre-builds? Were the labs at Hybercell included in the pre-build program?
The labs at Hybercell were built by Taconic before Hybercell was actually online. Now, I mean, that's a little bit of a misconception because Hybercell did come on as we were building them. but ultimately they were designed and in construction previous to Hybrid-Cell. And what we've kind of said was, we understand certain things about the market in terms of the biotech market from our history. Like I said, we're an 85-year-old company. We've been doing a lot of commercial science work in Boston, Cambridge in particular, but other locales as well as the West Coast, and we're particularly strong as well. So we've taken a lot of that benchmarking information that we've got and tried to be honest with you, tried to hit the highest possible common denominator. So in other words, get us 75, 80% of the way there, and then allow Hybrid-Cell to come in and manipulate the space ever so slightly because of the maximized flexibility we designed in order to meet their more specific needs. And thankfully, that one has proven incredibly successful in that regard.
Great, thank you.
And Nancy, I would add to that, you know, all of these New York projects are going to require some form of pre-build at this point to help these smaller companies get going. We're looking at that also at 95 Green and some of the other pieces to at least do some of that. I think it's essential.
Yeah, the step out space is going to be the biggest demand.
Mhm. Okay, good. Thank you. Let's move on. Chris Horsch, would you like to give us a little intro on yourself and what you're working on?
Certainly. Thank you, Bill. Good morning. Good morning, all. I'm Chris Horsch. I'm with JB&B. We are a 105-year-old consulting engineering firm in New York City, and my particular focus is on healthcare and life sciences. We are consulting engineers and provide design services for HVAC, electrical, plumbing, fire protection, and low voltage systems. In addition, we have a full array of field services and we offer including commissioning, advisory services, and testing and balancing. I just wanted to thank Don, Brooks, and Matt for highlighting most of our portfolio that we've been doing these days. So we're working on the majority of those projects, and not to repeat ourselves, but I wanted to take a different tack this morning with our time together. So if you would go to the next slide, please. Next slide, Sam. So I wanted to take a few minutes this morning to discuss the existing building market in the tri-state area. As we have seen over the past few years, many of these existing buildings have a potential for conversion to life science occupancy. In my opinion, the key factors to look at when debating a life science conversion are floor loading, available or potential shaft space within the building, location, speed to market, flexibility, and user experience. Outside factors like the trend for life science occupancy to be less chemical-based and more computational-based and focused on collaboration help the converting of these assets. Finally, as there are more systems that are required for a life science occupancy, having space for the equipment serving the labs that is maintainable and energy efficient is important. Next slide, please. Take, for example, a white box floor, core and shell ready for an office space. This one happens to be just under 12 feet floor to floor. Traditionally, you'd say no way for a life science occupancy of that floor to floor height, looking at more like 14 to 15 feet. By leveraging the base building system that exists for the office portion of the laboratory occupancy and supplementing the laboratory portion only, we were able to create a lab that felt like it had ceiling heights above 9 feet, when in reality they were 8'6". The other piece to this is to leverage new technology in the form of chill beams, direct outside air boxes, VRF units, etc., in order to minimize the traditional 12 air changes per hour the laboratories were designed for. By doing so, we are able to reduce the outside air and general exhaust distribution and use chilled water as our cooling medium, which is more energy efficient and space efficient as you're replacing large ducts with small pipes. Next slide, please. So as you can see, by routing the ductwork and all the services in a traditional fashion and coordinating properly, you get the look and feel of a much taller space, which is what these two pictures represent. Next slide, please. Other equipment that needs to have space allocated are high dilution, high plume cannon fans seen on the left. They are required to be on a roof and the fume hoods ducted directly to them, thereby requiring shaft space. There are creative ways to add shafts to a building, but it is building dependent. In addition to the cannon fans, additional plumbing systems are required, air compressors, nitrogen generators, potentially RODI systems, although some of those can be locally installed now, but as you can see, they all take up space. So looking for mechanical space is very, very important. Next slide, please. The laboratory of mechanical systems, air handling units, and chiller plants can be provided in mechanical spaces, basements, roof areas, or occupied floors. By going to a modular design, not only is it able to fit within a 12-foot floor-to-floor height, but it offers redundancy, reliability, and flexibility for adding or deleting modules as tenants occupy buildings. Having the building laboratory ready, but divorcing the laboratory from the office portion, the building can be flexible to every changing market, and the capital expenses can be kept to a minimum until their tenants are ready to sign leases. So as you can see, the air handling units are creatively designed and piped, and your modular chiller plant on the right is in a nice row configuration. Again, all fitting in a 12-foot floor-to-floor. Next slide, please. So I will close by saying that the laboratories of the 21st century have the look and feel of a tech company corporate office with the collaboration spaces and open laboratory design, instead of the laboratories that are thought of with closed off walls, individual benches, and minimal daylight. And Nancy had highlighted those very early this morning. The 1900s labs are the feel of the dark and fiefdoms, but the laboratories of today are bright, they're airy, they're collaborative, and they're purpose built for that science to really take off. So these spaces can mimic out of the ground construction and purpose-built laboratories within an existing building. So thank you, Bill.
Oh, thank you. And I think the fact that everybody mentioned your projects previously is just a testament to your expertise. So you can take that from me.
Thank you.
All right. Okay, my friend Joe Whalen. We're both builders. So Joe, could you give us a little introduction to yourself and what about what Lend-Lease is working on right now?
Yep, sure, Bill. Thanks for having me. Lend-Lease is a global company. My name is Joe Whalen, Senior Vice President at Lend-Lease, Operations and Construction. Spent most of my career at Lend-Lease in healthcare, and in New York, life sciences falls under the healthcare group. Lend-Lease overall, for those of you who don't know, we're an Australian company. We work in 4 sectors, 4 regions across the world: Australia, Asia, Europe, and Americas. We have a life science capabilities across all 4 regions. Next slide. Oh, didn't come up too well. So we've been in the life science industry since 1979 in Americas. We have over 300 dedicated life science professionals. We've done $5.7 billion worth of volume in America with 14 million square feet completed. And as everybody has mentioned previously, our repeat life science clients is a big key to our success. Next slide. These are some of the clients that we have currently. Merck, Bristol Myers, Amgen. We're currently working with now across the country in California, Massachusetts, and New Jersey. We prefer to get in the door early on projects. We like to do integrated delivery. We love design build and design assist delivery methodology. Next slide. In Asia, specifically Singapore, we're big in manufacturing on the life sciences side. And in Americas, we're also big in manufacturing. We're big in Massachusetts, North Carolina. Merck has been keeping us very busy at the West Point campus with over $4 billion worth of work that's led by Steve Imberling and his team there. Steve also supports our life sciences in New York as we're kind of coming into this new era of life science with the private developers. Next slide. So this is more traditional for Lend-Lease New York, which is the laboratory research. You see some names up there that have been mainstays in the institutional: New York Presbyterian, NYU, Winthrop, Mount Sinai. We've been delivering these projects for the last 30 years, which Bill was a part of that team back in the day. Next slide. So this is where we're at today. This is pretty exciting for us to be a part of the Manhattanville district. In the background, just north of Hamilton Heights, you see New York Presbyterian, Columbia, the Autobahn. As you come further south, you have CUNY and the New York Structural Blood Center. And as you come into the basin, you know, we made a home at Columbia since 2008. We spent over 10 years there developing the Jerome Green, Lenfest, and doing the foundations for the new business school. This is a pretty exciting community. Skanska had finished the Forum building, and now in 2020, pre-COVID, you could really see this sector being activated. A lot of people on the streets using the buildings. It was really nice to see. And as you go east, the factory district, you have Janus Properties has developed a nice little campus, which is ready to go for life sciences. They've really done a really nice job with the Tasty building. They spent a lot of time designing that. Next slide. This is the Drugrom Green Center. This is, again, Columbia University. This was a Renzo piano design, a little over 450,000 square feet, very unique, double curtain wall. What's nice about this is the glass at the first floor and the campus as an entryway to the Manhattanville district. It's just a really nice campus to be a part of and walk. It's not just a typical lab building. It really does bring the community onto the campus. And as you move east towards the factory district, I think that the Janus properties really complement that, call it Life Science Avenue. Next slide. This is the Tasty building, again, developed by Janus Properties, a little over 300,000 square feet. A couple of folks had mentioned lab ready, lab friendly. This is a lab ready building. I don't know what's been advertised on the street, but I will tell you, this is a lab building. The flexibility of this building is in how the air handler units and the air systems are delivered. You have the ability to split floors, east and west, into a 2-tenant occupancy, or you can take multi-floors. It's very flexible, very dynamic building, and it was built specifically for lab. So I think they're going to have a lot of really good success, especially with those startup companies coming into the New York market. I will say that this was my first private developer deal. Typically, in the past, it's been more institutional clients or life science developers such as Alexandria and Biomed. So this was different. It was a good experience, and I definitely see, in the last 6 months, we're getting approached by more and more private developers getting into life science for the first time. So it's exciting to see. And that's all I have.
Thank you, Joe. Amazing square footage in that building. It's enormous.
It's deceiving, though.
Yeah. Are they going to be able to split it up into? They're going to split it up, right, into smaller. So you're going to have a mixture of larger sort of scale tenants and then the smaller sort of startups.
Yeah, the lower floors, it's a pretty big footplate. You can get two 15,000 square foot labs, which is a nice size for a startup. And as you go up the building, it skinnies up a little bit, but it's a very nice layout, lots of light. You know, it's positioned well. It's in a really good location right next to Columbia. And I think they're going to do really well with Malthouse across the street and the Mink House. So.
And Slice is your architect on there?
Yeah, we have Slice and BR+A.
Cool.
They've been great. You know, BR+A is a mainstay in New York and Boston. Very successful.
Good, excellent. Thank you very much. So, last but not least, Theo, would you like to give us an introduction? You're a builder as well as myself and Joe. So you can give us a little bit about yourself and the projects that you're working on right now. That would be good for us, please.
Sure. Thanks for having me. My name is Theodora Diamantis. Joe, thanks for the shout out on the forum. I'm a vice president with Scanska, and it's an honor to be talking to you today and continuing the discussion of creating life science environments in New York City. Next slide. Next slide. Skanska is a global construction and development company. We're based in Sweden. Skanska has a strong presence in the US with 28 offices and our headquarters here in New York City. Next slide. Skanska currently has 1.8 billion in active science and technology projects across all market sectors. Our entire portfolio includes 17 billion completed science and technology projects. Interesting fact with this growing market sector, Skanska has developed an in-house life sciences advisory council, which is dedicated to providing technical knowledge and resources to support our regional offices in the life sciences and technology markets. Next slide. Familiar screen, you've seen this before. Our corporate headquarters in the 90s was located in New Jersey. It just so happens that the pharmaceutical industry giants, like the names you see on the screen, were also in New Jersey. As a result, Skanska built its reputation as a leader in the pharmaceutical construction industry. And over the years, this reputation and our history of success naturally expanded our expertise into other similar markets, more specifically healthcare and life sciences. Next slide. Try and go through these quickly. Next few slides are examples of some of the projects we have completed locally. First one here is NYU Langone, 20,000 square foot renovation that included open and private labs, offices, as well as conference centers and event spaces. Next slide. Another familiar, next slide, please. Yep, another familiar client, Regeneron, mentioned before, located in Sleepy Hollow. It's a current project. It's ongoing. It's a fit out of a DNA learning center and the renovation and exterior restoration of 120,000 square foot office space. Next slide. This project too is a DNA learning center, Cold Springs Harbor at City Tech. Next slide. This project's near and dear to my heart. Spent a few years as a manager on this project, the SUNY University CUNY and College Advanced Science Research Center in Harlem. This is a state-of-the-art research building. It supports the university, as well as visiting scientists from other institutions. The two buildings on this campus were over 400,000 square feet. And they house an extensive range of research facilities, to name a few, nanotechnology, biology, even we had a vivarium, animal research, astrology as well. The project also included clean room labs, a vivarium, and gathering spaces, which is instrumental in collaboration. Had a 100-seat lecture hall, outdoor green spaces, and a green roof that was above the shared ground floor between the two towers. Next slide. This is a current project, the Public Health Laboratory, also in Harlem. This facility was the world's first municipal bacteriological laboratory established in the late 1800s. At its current facility on First Avenue on the east side, it performs tests on more than 200,000 clinical and environmental specimens per year. This will be a new 10-story, 230,000 square foot building. And really the goals are to increase flexibility, which you've been hearing all along, and efficiencies for its functions. The building will house labs for virology, environmental sciences, microbiology. We'll have a BSL-3 lab, and we'll also have an Article 28 space, a walk-in clinic. Next slide. The site poses some challenges. It's adjacent to the Harlem Hospital campus. And this was to give the New York City Department of Health and Mental Hygiene more flexibility and help its staff work more efficiently in the event of a public health crisis or emergency. It's a bit small, but the access is off of Fifth Avenue. And it's a dead-end street, 136th Street. So we share that road with Harlem Hospital and their emergency ambulances. So you can imagine there's a lot of effort and coordination that goes into deliveries. Next slide, please. As mentioned, early engagement of a CM can ensure collaboration that results in meeting those target budgets and also resolve constructability and or phasing issues. This is just an example of a tool Skanska uses. It's called Scanstometrics. It's a proprietary tool, and it's used to enhance our initial cost models and make them more robust and ensure their reliability. Essentially, it's a database. It includes as-built project data. We have over 200 Skanska projects, and the costs are adjusted by location and date so that we can compare them to a current estimate or project in development. And data can be pulled that includes steel density, exterior facades, ductwork density, light fixtures per square foot. You're looking at one now that focuses on the envelope of the building, which more often than not is a major cost driver for new buildings. So there's a lot of information on this specific sheets, but it is showing you exterior wall to glass ratio, exterior facade cost per square foot, percentage of wall area by type of wall. So it's a lot of information, and it is a powerful tool. Next slide. This one focuses on another cost driver, electrical. And as you can see, 14 projects, specifically life science projects, were pulled here. And we compare and offer our clients benchmarking. Next slide. Skanska's life sciences market is primarily focused on institutions. Therefore, we have the advantage of engaging the experts and users of the building in the very early stages of design. And that includes the scientists, facilities management, IT, and this is critical on our projects. On the screen are just some of the lessons learned. MEP infrastructure is a major component of these facilities, as we all know. And it's important to understand what systems are going to require redundancy or have dedicated systems. You know, we've lessons learned, you know, critical power, emergency power was not included in some of our labs or for some of the equipment until the scientists were brought on much later during construction. And, you know, that poses a schedule and cost impact. And we like to address those earlier. You know, we've learned a lot over the last decade. but this is definitely a lesson learned. The selection of lab casework and lab equipment in some cases will drive the infrastructure design. And obviously with new technology constantly emerging, lab equipment selections don't occur early in design. In fact, sometimes they occur later in construction. Therefore, it's important to pre-plan for this equipment of specialty rooms by building just enough to accommodate them, but not too much so that you don't find yourself reworking areas that drive cost and time to the project. Next slide. Oh, okay. This concludes, I guess, my presentation. We take pride in building what matters, and we definitely believe these projects matter. And we're really fortunate to be involved in many of the earlier life science projects that have become a catalyst for interdisciplinary scientific research, shared knowledge, and collaboration. So thank you.
Thank you, Theo. We appreciate all of your insight there on everything that Scansca is working on. Nancy, was there another question that came in that you wanted to address or no?
No, that I think
No.
someone was just kind of correcting some language there. I'm not sure. We need to cover that.
Maybe,
so let's bring everybody together and maybe have a conversation.
Sure. Okay. You know, I've got a few things here that have come up just in the conversation this morning that I'd really like to dive in a little deeper on. So, you know, Matt, I wanted to ask you, yourself and Chris, a question about the project that you've been working on in Long Island City, the one that you showcased. Is it Inno Labs?
Yes.
What were your biggest sort of challenges there in terms of, I know you've touched on a few of them, but I just wanted to focus a little bit more on that particular building. What were your design issues that you guys had to sort of grapple with on that job? I'm just curious.
So that project was a renovation project of an existing building. And in fact, it was multiple buildings stitched together. So I would say some of the bigger challenges we faced on that were the column grid spacing. We found ways to overcome some of that or reinforce and eliminate some of that. In addition to that, I would say, you know, the shape itself of the site, you know, was a bit of a challenge. And I think we came up with a really interesting strategy for how to approach mitigating that and enabling us to bring the flexibility to the floor plate because of the odd shape that it was. And I think we've managed to overcome that and bring the flexibility to the floor plate. Those were probably, in my opinion, the two biggest challenges from a design perspective. I'm happy to listen to Chris's thoughts on that. He may say me, so I hope he doesn't.
I would never say that in a public forum. No, some of the other challenges were the incoming services were a challenge and utilizing the basement space for our mechanical systems. Obviously, risers and shaft space and dealing with very short floor-to-floor heights, and trying to overcome those with the future distribution for the systems and for the occupants, and making sure that we hit Matt's ceiling heights that he wants. And then the roof space was a real challenge because it had limited floor loading available. So being able to spread the equipment out appropriately, making sure that we could get everything on the roof and then get it distributed down the building were the big challenges that we faced.
Yeah, roughly half the roof area on that building is existing building and roughly half of it is new. So obviously we felt we were able to overcome that with the new spaces in terms of the design, but dealing with the existing conditions did represent some challenges that with regard to loading, as Chris was suggesting.
So how were the bones of that building? I mean, did you have to go right back to basics with it, or was it concrete? It's a concrete frame or steel?
It is a mix because it is three buildings stitched together. So and there is no consistent structural system there. In fact, it's iron in some spots.
Wow.
So yeah, there was some definitive addressing of that.
Right. Appreciate it. Just changing a little bit here. I want to sort of address this question to all of our architectural colleagues here. So that's Brooks and Don and Matt. I'm interested in, are you seeing a shift in the square foot area that people are looking for? And I'm asking that for a number of different reasons. I realize there's a lot of startup as well, so that might well be, there's a lot of interest around that right now, so, and a lot of movement in it. So there may be some smaller areas, but then I was thinking to myself, given what we've been through in the last few months and what's, how we're going, what the new way of working is going to be, do you think that could you comment on that also, in that maybe some of these firms might need a little bit more floor space given how we're going to work, or how people are going to work, going forward? Just curious what you would think about that.
Bill, I would just jump in and say that, lab spaces in general are much cleaner than any office space out there. And, the idea that when you go to a lab building, you have a much higher quality of air. And, thanks to Chris and folks like JB&B really making those spaces much better from a air quality perspective and air changes. So it's not necessarily that those spaces need to be, more controlled like a regular office space. The office spaces within the buildings can be, complemented potentially with a little more air circulation in space. But we haven't seen that the labs themselves have had any effect because of the clean air environment that they're already in.
Bill, we've seen in terms of the market, we've seen some of the scales reducing some in terms of the ask. I think
that's what I was thinking. Right.
Yeah, Hybricell, as an example, is about 15,000 rentable square feet. And I think that is what we're seeing right now. Is nothing is universal, but that's what we're seeing more as the high side ask, as opposed to the 30,000-40,000 square foot tenants. And in fact, we're seeing a few more of the kind of smaller scale, people looking for, 5,000 to 10,000 rentable square feet spaces, as opposed to the 15 to 20 that we were hearing early in the process.
Yeah, what we're seeing, it certainly aligns with what Matt and Brooks were saying. But what we're also seeing is a very high premium placed on a flexible floor plate partie, if you will, and to have it really work well, it has to be a very economical flexibility that we're going to design for, because the market is going to continue to change over time, and we can't design to meet just one particular point. So while there might be a trend downward at the moment to hit the kind of 15,000 square foot lab space, that could change course in a year or two or three, and suddenly it's going to uptick again. So what we're trying to do is actually kind of test fit a variety of scenarios. We do, we stress test our designs to optimize for flexibility without building in a lot of upfront capital cost. And that includes not only space planning issues, but also mechanical planning issues that we look at with mechanical consultants, because there's also a shifting trend in the ratio of wet to dry research. And we know that that's going to continue to evolve over time. So adaptability there is pretty important. And then on the initial point that you brought up, which I think was kind of COVID related, we're seeing some of our clients who are occupying space that we completed for them some years ago, they've actually divided their workforces during COVID. The people who need to put their hands on the machines, on the experiments, obviously they have to get to the labs. There's no alternative to that. But other members of their population can work from home, and they're doing the same thing that many of us are doing right now, and only coming in when needed. Because of course, in New York City, the challenge is the lab may be very clean, but how are you going to get there, and how are you going to get home?
That's going to unfortunately be our challenge going forward for every kind of building we're doing. Yeah. But as Chris said in his, to your point on the modularity of these systems, to be able to slowly build out your mechanical systems as the buildings require it, because in that pipeline, or the drug discovery pipeline thing I was talking about earlier, we're very early on in this phase, but these buildings, as Don is saying, are going to evolve in the next 5 to 10 years. There's going to need to be a whole different kind of setup for these spaces. So the ultimate flexibility is what we're kind of shooting for in every respect, I think.
Yeah, and the beauty there is that as long as you've got the space allocated, then you don't have to put the capital out up front. And a lab today is more like an enhanced office space with a few synergies and a little bit of nuances. But in terms of the infrastructure, you build out what you have to build out for an office, and then you can supplement it in the future as the tenants sign leases and things like that for the modularity and flexibility.
Yeah,
As long as the space is allocated.
Right.
Yeah, and as they need it too, because there is this move towards digital signs. That's potentially some companies don't need very much wet lab at all, as you guys were saying, and I think that's going to evolve. Some companies may need a lot more, but that's kind of a little further down the line for some of these guys. So it is going to be that the flexibility is going to be the key, not necessarily any COVID response right now.
And the definition of flexibility, and this is something that we also look at with our friends on the construction side, is imagine a building that's partially occupied, and now here comes a new tenant, or an existing tenant needs a change. How easy will it be to implement those changes without disrupting a building that's occupied? Because that can be a huge setback to tenants. So we want to make it builder friendly too.
Right. Something we did at InnoLabs, you mentioned earlier, Bill, was we set up multiple cores, what we called miniature cores, in order to better facilitate exactly what Don is suggesting, so that you're not having to shut an entire floor down or large portions of the building in order to address that flexibility from a constructability perspective.
Yeah, and appropriately finding dampers and valves and things like that to make sure that you can shift during construction and things like that are important. So multiple shafts, things of that nature.
I've got a related sort of question. I'm just thinking in the back of my mind. I was thinking about this last night, Chris, when I was looking at some of the things you're going to be talking about. So in New York City, local law 97, right? How do clients, how do you look? There's a lot in that, right? And it's a big deal. And I know that you're planning and designing around all the requirements of the energy efficiencies and all the rest of it. But how does that impact when you're talking to a client about a building they're looking at or a space they're looking at? Is that an off-putting thing? I'm just curious. I'm not suggesting it is. I'm just asking if do you have to educate clients on that when they come into New York City?
There is a piece of education there in terms of local law 97 and the deep carbon reduction.
Right.
And you look at it in two different ways. You've got the short term, which is between now and 2030, and then you've got 2030 and beyond. And the real conversation has to happen with the client up front. Is this a long-term asset that you want to hold on to, or is this a get in and get out kind of flip? And there's two different approaches depending on the answer to that question. Right? For the long-term assets, we don't necessarily want to go all electric today. Right? The grid's not ready for it. Electricity is extremely expensive compared to gas right now, and those things. But you have to make the building, carbon-free ready, and you have to be able to flex that building in the future to an all-electric source. And that's what we're doing with a lot of these clients. Is not that we're building it out as all electric right now, but we're preparing the buildings to become electrified in the future. And with that, we're taking another look at how the energy is used in the building and what we could recapture before we send it to the out of doors. And we've come up with a lot of different ways for energy recovery, for reusing condenser water or transferring heat from the interior to the perimeter, and really trying to simplify the design, but still use every single ounce of energy within that building, trade it around the building before expelling it to the out of doors. And those are the conversations that we've been having. And we believe that we've got a pretty good handle on it and a lot of solutions that are available for that future proofing of those buildings.
And I would also add to that, any of the curtain wall and the exterior envelope is a critical component to try and make it as efficient as possible, even though we're throwing so much air out of the building. I think, we were all, both Matt and Don teams are really looking hard at making sure those are great curtain walls so that those projects can start becoming a little bit more efficient than they used to be.
Yeah, there's a lot of technology out there, right? I mean, between the chill beams, the direct outside air boxes to reduce the outside air components, slide everything to chilled water, heat recovery on the hot water side, smart track systems, and measured air systems on your cannon fans, heat recovery of the cannon fans. There's so much out there now, and there's a lot of moving parts and a lot of things that we can plug into a design to make it extremely energy efficient.
Skin design's an interesting perspective, though. It is a challenge in New York City with the way that square footages and zoning square footages and such are calculated when you're dealing with existing buildings, because oftentimes there's a low-tech method of approach with skin design to cut down on heat gain and things like that by having a deeper facade, but you're losing rentable square footage in the process, and finding the appropriate balance there, and maybe even at some point down the road addressing that with revenue or with the way that the city calculates zoning square footage is something that needs to be addressed. But I do think it's something that is, again, a low-tech version, a low-tech methodology for approaching things like Local Law 97 or just sustainability in general with regard to skin design. And I think it's something that should be reviewed again.
Yeah, and an interesting aspect of the changing code with this new local law is that it's now identifying and singling out requirements for specific building systems. So it used to be that you could look at a whole building energy model and make some choices about having a portion of your envelope be more efficient, another part be less, and it all kind of balanced out and you were compliant. But now there are some upper limits, and you just can't cross that line.
Yeah, and everything that you all said is 100% correct. The curtain wall and the integration between the curtain wall and the mechanical systems is really important. In our energy modeling group, we've found that these higher interior loaded buildings, the lab buildings and things like that, actually benefit from infiltration during certain points of the year in our climate. So you have to weigh that balance as well, because in certain times of the year when I'm getting that infiltration in the curtain wall, I'm actually getting a benefit from my mechanical systems because I'm getting that BTU out the door free, basically. So as you tighten down and go towards the passive house, we still have to look at that very carefully, because if I lose that infiltration, I'm losing some of my free cooling during the year.
So more holes in the building.
I'm not suggesting.
It's smart holes.
Some
Smart
operable
holes
windows,
in the building.
Chris. Can we have some operable
So,
windows?
Bill, we have another audience question.
Yep.
This is from Daniel Kastner. As you are providing multi-tenant spaces, are you finding that the landlords are providing common lab amenity space in situations where the individual tenant may not be able to afford to provide it themselves?
I would say from the variety of projects that we're doing, that's a big component, and it's all being evolving on some of these New York City projects. It's, I think, as Matt identified, a critical component to InnoLabs. And, it depends on, what the pro forma is for the landlord as well. How much can they afford at this point? But I think there's always a room left. We're always trying to provide additional amenity space, because I think there was a great point made. That's where a lot of the science happens, in these spaces where companies do interact and create casual kind of interaction that does change the science in a positive way. So you can't not do these without amenities as a component that join all of them together, not just one floor. I think you guys would probably agree with that, especially the one, Don, we worked on many years ago. There was that whole piece between labs and offices that made people interact. And I think that was, one of the first groups that really did it well.
Theodora, you must see this in your work with biolabs, right? You must have had to really focus on the shared support services for those companies that were in the incubator.
Yeah, that's a major focus of especially the institutional projects. They don't want to isolate these buildings to just the people doing the research. They want to engage the rest of the campus and the community. So, there's a big intent when it comes to creating inviting shared spaces, whether they be conference rooms, lecture halls, and food always attracts people. So, they tend to have cafes or cafeterias in these buildings as well. to promote collaboration and share knowledge. So yeah, we see that especially in our institutional buildings.
I think target tenant scale is a major component to this, though. I think if you've got a multi-tenant building and the tenant scale for those multiple tenants are smaller scale, then those are the types of tenants that will expect or require that type of space more so than larger scale tenants that would ultimately want to have those within their enclosed walls. So I think the tenant scale is a major component to this, and that should be something that's established maybe somewhat early.
I'm interested in talking about scale and size of buildings. So in terms of those institutional clients, Theo, you talked a little bit about, you fondly remember your project at CUNY there. Because now you're delivering on a public, right, a public lab. What lessons did you bring from that experience with CUNY to that new construction project that you've got underway there on that campus up in Harlem?
Well, just time has implemented lessons. For example, Hurricane Sandy forced designers to move major equipment off, the ground floor. Even though CUNY was on a hill, all the major infrastructure, switch gear, et cetera, was on the ground floor. You look at a building like the Public Health Laboratory building, everything's raised now, excluding the fire pumps, domestic water, everything is rising in these buildings. And that's just lessons learned, right? Another major factor is, CUNY was designed in 2D. So, flash forward, we had a lot of challenges there. We weren't just decreasing ceiling heights by inches. There were instances where we were talking feet. And, today everything's done in Revit. We do our own clash detection to, assist the design team. So, that's a major, change from project to project. We've learned communication within our neighborhoods. That's another important factor, right? Engaging the community.
Yes.
At Harlem, that's critical, right? And engaging the local labor workforce. We had a high MWBE participation. We exceeded our goal at CUNY, and we plan to do the same on the Public Health Lab. So, we've learned some lessons, like some of the other firms, they pride themselves in retention, and we do too. So, a good part of the staff that was on the CUNY project will be on the Public Health Lab project.
It's good that you've got that continuity. That's good.
Yeah.
So Joe, I'm just wondering what at the Tasty building are the kind of shared amenities that you've provided for in a multi-tenant situation?
Currently, there aren't any planned shared amenities in the building, Nancy. It's retail space at the ground floor. Hopefully for some, as Theodora mentioned, food. And then there's a lot of open terrace space for collaboration. So I think they have 3 main terraces throughout the building, which are nice amenities to have. And, obviously the ability to add in circulation stairs, communication stairs into the building for future tenants.
Have you finished up? Have you finished up there now, Joe? Are you at completion there, or are you still got a ways to go?
I'm fighting every day, Bill. I'm almost done.
No, the reason I'm asking is I'm curious as to, you must have had some, given what we've been going through in the last while, did they change? I mean, we get it on lots of different buildings, right? A lot of things have changed at the last minute, quick things, especially mechanical systems and that type of stuff. Have you had to deal with a lot of that on that building?
I think where the Janus really wants to focus their dollars is on the lobbies. They want to get the lobbies right.
Right.
I think that, they've done the landscaping, they've spent some time on, which, you know, I think they're doing they want to make the right product, right, for the environment, and they're doing a good job designing that. You know, it's going to be a Class A commercial office building / lab building, so they're doing the right job. But, you know, just to add to what Theodora mentioned about BIM, the one thing that is unique to me, that this was a private development, was that we did this 60% non-union. And, you know, early on, you know, I'm going to give my exec who ran the buyouts, he identified early on that the non-unions didn't have the capacity for coordination. So we third-partied the BIM, and it was a very successful choice. So just to echo what Theodora had mentioned, it's vital that you have that, and you want that when your tenants come in, so you can give them a record of what was put in place. So that is a big challenge with the non-union component. So as private developers come in and they want to do everything cheap, just keep in mind you do have to spend some bucks on the coordination.
Yeah, it's probably a good investment, all right? I mean,
oh, it's 100%, right? I mean, everything we do, right? I mean, you look at all the systems that Chris, you know, tries to get us to squeeze into, you know, 2 square feet. It's tough, right? And, you know, we do want to make sure we have the proper access, and, you know, at the end of the day, we want to make sure the client's getting the right project and the right delivery.
yes.
Joe, in Chris's defense, it's us who squeezes him into 2 square feet.
No, and Joe, you brought up a great point about BIM and coordination. You know, the future and where we're headed is embracing the drafters and the detailers early in the process. So getting them as part of the CM and the design team to really focus on those crunch areas early. You know, the thought is that you find one mistake on paper, you know, it pays for the entire process. You find 2, you're ahead of the game.
Yep.
And so we've been advocating for bringing those detailers on board, either, you know, DDs or 50% CDs, and really having them focus on the coordination of certain areas. And we've done that on 2 or 3 projects, and it's been extremely successful.
Yeah, I would parrot that in our Boston market, where we have a virtual design and construction wing of the firm, and we really try and end up with a model first approach. And we'd like to have an implementation model instead of construction documents, which is the mix between the design and the fabricators as well. So that those models that end up going into the hands of, you know, Theodora and Joseph and you, Bill, are much more, you know, complete, represent exactly what you're going to build as opposed to what we think you should be building.
Mm-hmm.
You know, we as designers and architects have, you know, a lot of good ideas, as well as Chris, but how you're going to build it and who's going to build it really makes the difference. And if the sooner we can get them into the process, a much better product comes out on the end.
Yeah. This also really affects the way we all collectively craft a design and construction schedule. And one of the things that I've been recommending lately, and I've been surprised at how many people have said, sure, let's do that, is to actually shorten the construction document phase and give that time to design development, because very often, in order to meet a buyout schedule where it might be a delegated design curtain wall kind of a thing, you know, we need to get bid documents out on the street, and for the curtain wall, it'll often be, you know, a nice design development package. Well, to get it to the point where it's going to be reasonably smooth sailing, if we can borrow a month from CDs and move it into DD, it actually makes for a much better process. And by the time we're in CDs, we're kind of tidying up interior details and things like that that can wait a little bit longer, and having less coordination to do, less clash detection to do with multiple disciplines, the owner and the builder.
Yeah, and to echo that, the other opportunity is, you know, obviously pre-purchasing the mechanical equipment,
Yeah.
and then trying to get into prefab as opposed to on-site fab, and then also splitting packages. So infrastructure packages, mechanical room packages, and then letting the fit outs and the lobbies and things like that follow in some of those smaller packages, so that you get the bulk of the equipment and ductwork into fabrication, into the hands of the contractors faster.
Right. So it's
Yeah.
actually been very constructive to kind of rethink and say, okay, what issues do we need to button up, lock down so that, you know, the project can move ahead and still leave some detailing left for the last couple of months.
I would say speed to market is essential in
Yeah.
this
Yeah,
this
absolutely.
particular market,
Yeah.
without a doubt.
So we have about five minutes left here. So something I wanted to do was it's been a really great conversation, and I wanted to go around everyone and just look in your crystal ball. The next 2 or 3 years, what do you see? What do you see developing? What do you see the new trends in life science? And what do you think we're going to be? I mean, we're going to be having this symposium for many, many years. So what are we going to be talking about in the next 2 or 3 years? I'm just curious what everybody thinks about that. Take it away. whoever
Any
wants to go.
particular order? No? Okay, I'll jump in then. You know,
Go ahead.
I think the market in the New York City greater metro area, it's definitely heating up. We're all seeing that. There is still a little bit of hesitation. I don't think we've really hit that part of the bell curve where it's, you know, we know the ship has fully left the harbor and is going full speed. I think we're very close to that. Knowing exactly when that's going to happen is a bit uncertain, but we can design around those unknowns by building in flexibility and doing really careful upfront work together with our commercial venture partners to make sure that they're not taking on a degree of risk that would make them uncomfortable. And I think also looking at sites and buildings, including repositioning existing buildings, can shave a year or two off of delivery to market. And there's probably a lot of building stock in the city. We know there is that's eligible.
Freeing up cost wise, right?
Yeah.
What do you think, Brooks?
Yeah, I would just add to Don's point that, you know, we are seeing a shift in New York in a way that's quite dramatic. Obviously, the office space of the 2 years ago is much more available now, and I think the repositioned pieces are becoming much more attractive for this type of user. But we wouldn't want to also change what's going on in New York. What we do in life science buildings can be implemented in many of the office buildings at a smaller, less robust scale in order to allow those buildings to become much more usable for just the regular office environment. So I think we're going to see a kind of an integration. And I think, you know, maybe it was Matt who mentioned that these building spaces are very much like tech spaces anyway, which were the kind of trend for office buildings going forward. And I think there's going to be a merging between office buildings and lab buildings in regards to the stuff that Christopher and his colleagues in the mechanical field are doing to make them capable to flex for these new environments that we're going to be looking at. And if you need to and can transition those buildings to lab at any time, modularly, we're going to have that ability with any of the repositions and new buildings that we're designing. So it's going to be, these buildings are going to have that muscle to transition, provide great, you know, resources for people that just want straight office buildings, and you know, with a higher level of, you know, certainty that their air is going to be super clean. So you first have to get there, but once you're there, you should feel super safe. I think that's where we're going to end up in the next 5 years.
Okay. Theo, how cloudy is your crystal ball? Is it crystal clear or is it?
No, it's very cloudy.
Cloudy.
And I think, you know, my colleagues really have summed up the short term, 3 to 5 years. But, you know, thinking beyond that, you know, how much is robotics going to play a role in, you know, lab research and thinking about that in the future is something that I see. So I would just add that.
Good, thank you.
I might counter that a little bit. I'm not disagreeing with you, Theodora, but I would maybe add another facet to it, which I think AI and big data is really going to be, especially as we're looking at you know, a pandemic where we're starting to try and find ways to be more remote or enable us to be more remote. I think the ability for AI to actually focus the science to a handful as opposed to the old high throughput screening methodologies, but focus them on a handful of potential solutions that are far more vetted on the computers is probably something that we're going to see a little more of given the pressures. But I think more cross-disciplinary work and much greater partnering with the commercial and the healthcare entities, in my opinion, because I think they're starting to realize that there is an enormous synergy between the two of them as pertains to approaching the troubles that we're facing, or that the science industry is facing as in days like today.
We got a minute. We got a minute left for Chris and Joe.
So yeah, having shaken my magic 8-ball earlier this morning, it said positive outlook, right? So I think the life science and science and technology is going to continue to grow. The clusters will form, and New York City is great. It can absorb 10, 15 million square feet without even blinking. And these existing buildings and the repositioning and adaptive reuse is going to happen anyway because of the local laws and the energy reduction. So the infrastructure upgrades are going to be happening, and the shifts are going to be happening. And for a little bit of space allocation, why not make it lab ready or lab light, and then see where the market goes.
What about you, Joe?
We went from this institutional life science over the last 20 years into what I'm going to call the private future. And I'm really excited to see what the infusion of private equity dollars does to, the types of buildings that are delivered. I think they're going to be unique and, very sleek. And I'm excited for that. I think it's going to be refreshing.
And you're going to build them all, right?
No, I got to give some to Theodora.
Yeah, come on, share.
Right. Well, thank you very much. Wonderful. Great. Nice to see you all again. I've met so many of you over the years. Wonderful to see you all today.
Great job, Bill.
No, thank you very much.
Bill.
It's great.
Yep,
Nancy, thank you.
Thank you, Bill. Thank you,
Thank you.
fellow
Great.
panelists.
Thanks, everybody.
That was great.
Great.
All right.
Thank you.
All right. Bye.
Good to see
Really
you.
terrific.
Bye.
So,
Yep. Thank you, Nancy.
obviously, we're very excited about what's going on with all of the projects that are happening in the city right now, and where they're happening. And we've just heard from the people who are building them. So we're learning a lot and we're building a lot. Now we're going to shift gears, which is actually very, very exciting. And we're going to shift gears to the tenant side of the equation and hear from the companies who are building the New York City Life Science Cluster. In the first panel that will happen after our break, we'll meet the New York City Life Science companies that are leading the way. And that panel will be moderated by John Pennant of Eisner Amper. And then we will shift to the spectrum of companies that are in New York City, from therapeutic companies to diagnostic companies to tools and technologies to synthetic biology. And you'll hear a lot about the different kinds of technologies that the companies are using to develop their products